Third video of the day, here we go. I'm just blasting videos as if there is no tomorrow. So I hope you guys enjoy it. Give me a thumbs up if you like it and subscribe. Join the Facebook group to ask for more questions. So let's do it. 101 Symmetric Tree. So you're giving a binary tree and you have to check if one is the mirror of the other. I'd recommend you to do by itself. On a superficial level, it doesn't look that much harder than the last problem we did, which is the minimum depth of a tree. But if you actually try to do it, I find it harder, because usually on tree problems what you do is you do a depth first search. What depth first search, you go all the way to the left, and then you keep like moving up and down according to the recursion call. But it doesn't really work here, because you would have to go all the way to the left and all the way to the right. There is a way of doing it, but it's not as intuitive as other problems, in my opinion. So we have two solutions which work. An iterative one, which doesn't use recursion, uses some sort of loop, and the recursion solution. Usually I recommend using recursion for tree problems, but I actually think it's more elegant in this one to use a iterative approach. So let's look at an iterative approach. What you're gonna do is you're gonna return true if it's none, but because if there's none, it's true. It's symmetric. There's nothing to be symmetric, actually. And then the cool thing that I thought was genius was you create two stacks. Stack one. Oh, it's white, but you guys can kind of see, right? And stack two. And as you're traversing down the tree to the left and to the right, you're pushing elements here. So he creates two stacks, and first he puts the nodes to the left and to the right. So he puts 2 and 2. And then he keeps doing it. He puts the ones to the left. He puts the one to the left and to the right. To the right and to the left. Because what we're doing is checking left, right, right, and left. They're actually a mirror of each other. And then if they're symmetric, when you pop these elements here, they should always be equal. Otherwise, they are not symmetric, right? So that's what he does here. So while there is elements in the stack, while you have elements in the stack, you pop it. And if both are empty, which means yeah, so if both are empty, you continue. If they have different values, or if there's something weird here, like if one is none and the other is not none, you return false. Otherwise, you append to the left and to the right, and you append to the left and to the right. This here will happen when, for example, you have something like here. You put something to the left, to the right, to the right, to the left, and at some point the stack will be empty. So you return false. And you keep pushing to the stack, popping and checking if they are equal or not. If they are equal, you keep pushing to the stack. If they're not equal, you return false. So that's a really cool approach, I thought. And I think that's how I would do this problem. I think it's more intuitive. The other one is recursive. So you kind of do the same. You create a function called symmetric. If root is none, you return true, because again, it's 0. There is nothing there. Otherwise, you're gonna call asymmetric recursion. So asymmetric recursion does the same thing as the while loop. So if both are none, you return true. If one is none and the other is not, or they have different values, you return false. Otherwise, you call the left of the left and the right of the right. And then you call the left, the right of the left, and the left of the right. So exactly like here. So you're calling the left of the left and the right of the right, and you're gonna call the right of the left, and by right of the left I mean in reference to the root, and the left of the right. And you keep calling until you either return true or you return false. I think for this problem, for this particular problem, I would take a stack approach. So I hope you guys enjoy it. It's a really cool problem. Try to do it by yourselves. And yeah, I have one more video I'll be posting today. Hope you guys enjoyed. Give me your thumbs up. Share it with your friends. And let's be great at coding.